Hello everyone, my name is Ding Ma, I come from Harbin Institute of Technology. Today I will give you a presentation named Tracking by Natural Language Specification with Long Short-Term Context Decoupling. Most TNL methods directly fuse the visual and linguistic contents to localize the specific target object. However, the textual query describes long-term context information, which may be inconsistent with the visual contents. In this paper, we propose a self-motivated feature decoupling strategy and a context modulation approach in Fusion module design, termed Decouple TNL. Decouple TNL is implemented with transformers because the attention module is qualified to establish intra- and intermodality correspondence for vision and language. Our contributions are listed as follows. Firstly, we analyze the limitations of TNL trackers and propose a novel long short-term context decoupling framework for tracking by NL description. It simultaneously models the long-term and short-term context information for a more robust representation of learning. Secondly, we propose a long short-term modulation module for injecting the long short-term context information into the current frame representation, making our model adaptively perceive dynamic and static surroundings. Finally, extensive experiments are conducted on 3 popular tracking benchmark datasets. The experimental results fully verify the effectiveness of our proposed method for tracking by the natural language specification. This page shows the overall architecture of Decouple TNL. There are 3 feature encoders used to extract the frame, video, and linguistic tokens, respectively. Then, we design 2 branches, i.e., the short-term context matching branch and long-term context perceiving branch, gathering meaningful long short-term context information with a short-term context matching task and a long-term context perceiving task. After that, we associate the frame tokens and the learned long short-term tokens representations through a long short-term modulation module. In the end, there is a prediction head for localizing the target object. As shown in this figure, we add the proposed context decoupling strategy to existing TNL trackers, including TNL, SNLT, Capsule TNL, and a DA switcher, initializing with only the natural language. Thanks to the adaptive context information learned by the context decoupling strategy, the baseline networks can generate the feature map or pose matrix of capsules more precisely. More visible in Figure 3, B and C, benefit from the proposed context decoupling strategy. These methods achieve better performance and converge faster. We evaluate trackers under 2 different initialization and tracking settings, NL only, light gray part in this table, and NL plus box, dark gray part in this table. We notice that Decouple TNL with NL only, achieving comparable performance against other trackers. We attribute such a favorable performance of Decouple TNL to the decoupling strategy. This page shows the qualitative analysis of context decoupling and SCM. The left figure visualizes the tokens of both branches, where it shows the score map differences with and without dual branches. SCM branch predicts better when the target undergoes dynamic changes. In contrast, the LCP branch consults representative exemplars from the textual query and consistently outputs high confidence for the case of large movement or reappear. Obviously, as shown in the right figure, the effect of the SCM branch is more pronounced when the target appearance changes dynamically. This page shows the qualitative analysis of LCP and LSM. As shown in the left figure, the superiority of the LCP branch is that when the target has a large displacement or reappears after being occluded, the model can accurately locate the target. As depicted in the right figure, models capitalizing on the LSM module achieve better accuracy, which demonstrates the advantage of the proposed fusion strategy. In summary, this paper proposes Decouple TNL, decoupling the context information into short-term and long-term forms. Extensive experiments show that the proposed Decouple TNL achieves significantly better performance against the state-of-the-art TNL trackers. The prominent efficacy of Decouple TNL would inspire researchers to pay attention to long short-term context modeling for tracking by the natural language specification.